cannot be cut off.
Oh, I mean later. So now it's recording, I assume.
Yes.
Okay.
Just like so.
Should put a watch on this wall somewhere.
Take off
Oh, sure.
Want it to be distracting when you move around the sound. Pedro's supposed to introduce you.
It felt so close.
Almost, huh? Gotta be a firewall, maybe.
I don't know. It would have been fun to present for before.
Yeah. It's Jerry. Do you remember Jerry?
Yeah, right.
A lot of familiar faces for you, huh?
Yeah. A lot of not.
Yeah, and the students.
Like research
the older-
institutes do it.
Yeah.
They change.
Pedro's cell phone.
Hello. Morning. Oh, these screens are so bright. Holy shit. I don't know how I'm wearing sunglasses.
Pedro? ¿Ya vienes a la presentación?
Big screen.
Vamos a verlo en 10:15. 16. Okay, bye. Bye. It's on its way.
Perfect. Hey, Fred.
Good to see you. Thanks for coming to visit.
Sure.
on his way.
What's it?
Pedro's on his way.
Is he here or is he driving?
He just said I'll be right up.
Okay.
So I just-
Hi, Denny. Welcome.
Thank you.
So it's my pleasure to introduce Denny, who needs no introduction, actually. He was here when he started working on Wikidata, and if he's the guy behind Wikidata, we're thrilled to have you here.
Thank you.
And so he's going to talk about Wikidata and beyond. I must confess, we're avid users of Wikidata,
Yes.
so we'd like to find out more.
Perfect.
Thank you.
Thank you for the kind words, Pedro. If I speak too fast or not loud enough, please let me know. Especially, I'm not good at speaking loud, so give me some sign if I'm not. I want to start with a little story. The goal of the Wikimedia projects, like Wikipedia and the others, is to reach a world where everyone can share in the sum of all knowledge. So how good are we at that? This is the city of Winterthur in Switzerland. Beautiful little town, around 100,000 or so population. And Manuel Sachli is one of those people. He lives there and he's been an avid Wikipedian since basically the very early years of Wikipedia, like around 2003, 2004. He started to edit Wikipedia with topics of interest, and particularly with the interest to Winterthur itself. So he added a lot after the article on Winterthur about its history, geography, all this kind of informations. One of the pieces that he added was a section on the sister cities of Winterthur, which I include 2 other cities in Switzerland, one in Czech Republic, Pilsen, and one in Austria. So far, so good. Manuel has been keeping up the article up to date over the following years. He's still a Wikipedian, he's still editing, and he was working on these pages. Around the same time, someone created an article on the city of Ontario in California, which is just like 50 miles away to the east from here. So on a good day, it's 1 hour to drive there, but with traffic, usually probably 3 or 4, I don't know. So Ontario in California also has sister cities, also has an article, and the sister cities list, among others, Winterthur. So sister cities are usually reciprocal. The Ontario article is Winterthur, but the Winterthur article doesn't list Ontario. And in fact, Manuel, who has been collecting all kinds of information about Winterthur, never stumbled upon this information on a different page in Wikipedia. He never got the idea to randomly look for in Californian cities for some city claiming that Winterthur is a sister city. So this inconsistency has been there for almost a decade and no one noticed. So we're obviously not particularly good at actually allowing people to share in some of our knowledge because we had this information there. People were obviously interested in it, but they didn't have access to it at the right moment. They could have gone to the page, but there was nothing to actually push this information to them in some way to make it accessible when they actually needed it. And this is because content in natural language is just easily remaining hidden. It's really hard to access this knowledge and to do something with it, to act on it, to have a computer act on it so that the human can access it at the right moment when they actually need it. Enter Wikidata. So a few years later, Wikidata was created. What is Wikidata? So we started with a prototype at ISI, went back then to ISWC, and based on the prototype, we managed to get funding from the Allen Institute of Artificial Intelligence, the Gordon and Betty Moore Foundation, and Google. And then with this funding, we started working on Wikidata in Berlin in 2012. And since then, it has launched and grown quite a bit. It is an open knowledge graph that everyone can use under free license. It's a knowledge graph behind Wikipedia. More and more of Wikipedia is using actually Wikidata. I will get to this in detail a bit later. Provides structured linked data, persistent identifiers for all the entities in it, and it's available in about 300 different languages. One of the donors was IBM Watson, and in fact, the prize money from the Jeopardy challenge was donated to Wikidata as a thank you for the data they were using for Jeopardy. So this is the page for Ontario, California in Wikidata. So we have a lot of this structured information. It doesn't look as pretty as Wikipedia, not even close to that. Okay. So the first thing that we launched in Wikidata was the language links. How is this article represented in different Wikipedias? And this was a huge win already. It used to be that if there are, like in this case, 44 Wikipedias with articles about Ontario, California, each of those 44 Wikipedias would have links to the other 43 Wikipedias that have this article. So you can easily calculate there's a lot of links which are completely nonsensical to maintain in such a way. And what Wikidata did is centralized in one place. So we said, okay, well, these are the links, and every Wikipedia can just ask Wikidata, give me the links to the others, and Wikidata would tell and then display it in Wikipedia. So we removed more than 200 million lines of code from the Wikipedia, so now no one has to maintain anymore. This was a huge win in the beginning. It got a lot of goodwill from the community because of that, and this was the way that Wikidata kind of got into the Wikipedias. The other important meta information about an entity is the kind of term box that we have at the top. So we have the name for the entity in different languages. We have descriptions in our different languages. They use for disambiguation for finding which entity you actually mean. We have aliases, which you might be using for searching for it. And most importantly, we have this Q identifier for every single identity, for every single entity. So Ontario, California is known to Wikidata under the memorable name of Q488134. But this Q identifier is not really meant for human consumption. It's just a persistent identifier in the back end, so that we know that this is what this entity is referred to. And this allows us to understand the graph abstracted from the actual natural language. Because now what we can do is we can take this page on Wikidata in English and just switch it to, for example, Russian. So all we do is we change the labels of every entity and every property to Russian, and that's it. So the data is exactly the same. So you can go into you can check out under the Russian UI, edit it, and it will edit the same data as the English data because it's just the same data in the backend. So anyone can contribute in their own language to Wikidata, and it's available for everyone else in their language. So you can switch it to other language like Georgian. I just love the script, which is why I'm showing this one. Or in Hebrew and so on. We have about 300 languages where you can edit Wikidata, where you can read Wikidata and use it. Back to English. The other thing that we have are the statements, the boxes down here, which is kind of the meat of Wikidata. This is how the entities in Wikidata are connected to each other. Statements have a little bit more structure than subject, predicate, object. The core of it is the subject, predicate, object. So here we have two statements, one saying that, so the subject is always the subject of the page. So we're talking about Ontario and saying the property is twinned administrative body, which is the way that we're talking about sister cities. And then Winterthur is like the main object. At the same time, we can put qualifiers on each of those statements. Like in this case, we have saying the start time is 1982. So this is a qualifier of the actual triple. So we can have a little bit more expressivity than just SPO. Also, for every claim that we have, we can have different sources. So, and this is a very important part of Wikidata, to have references for every single statement, for every single claim. We say, what is the source that actually makes the statement? Why would you believe this claim? The important thing about Wikidata really is that Wikidata is not about the truth. We're not trying to define what reality is. We're just reflecting sources that we find and say, well, what are they saying? This is most important in order to avoid edit wars, avoid wiki wars between people who have different opinions, for example, on the capital of Jerusalem. It's much easier to say, well, according to the Israeli constitution, the capital of Jerusalem is, the capital of Israel is Jerusalem, but according to the Palestine authorities, it's not, and so on. So instead of having it fight out and have a single version of the truth, we actually allow for several data points together with the references, and people can then, based on the references, which are also structured data, filter them out and choose what they want to use or how they want to proceed. Okay, so this is how the information is represented in Wikidata. We have the predicate object with qualifiers and references on each of them. In that case, at some point after Wikidata started, actually surprisingly early, people were going through the Wikipedia pages and adding a lot of the information which was in the Wikipedia pages to Wikidata. So they were just going, saying, oh, here it says the sister cities, let's go to Wikidata, enter this information to Wikidata. And so slowly, more and more information from Wikipedia is being represented in Wikidata, which obviously has limitations, to which I will come later. And so Ontario, California has a number of sister cities coming from Wikipedia, and time passes on. Oh, sorry. How is this data actually used in the Wikipedias? So one thing is that actually anywhere in a Wikipedia page, we can make a query to Wikidata and ask for a specific datum. And the place where this is most used are in the info boxes, the pieces on the right. So you have information where, for example, like the population, instead of having the population written in text or in the Wikipedia page, just make a query to Wikidata and display it there. More and more Wikipedias are using this more and more. So some of the info boxes are now completely generated with data from Wikidata and are not represented locally at all. Which also means if someone edits in Wikidata, it's immediately reflected in that Wikipedia if they choose to use to do that this way. Different Wikipedias have different opinions on how trustworthy Wikipedia is. The best measure to see that is actually if the number of active editors on a given Wikipedia exceeds the number of active editors on Wikidata, they usually don't trust Wikidata. But as soon as the number of editors in Wikidata gets bigger than the one in Wikipedia, they say, oh, well, they have more eyeballs, we better trust them. This can also be from topic to topic differently. So it would totally make sense for the Croatian Wikipedia to trust on Croatian cities more themselves than Wikidata. But say for Japanese cities, they could just use the data from Wikidata because they don't have local people to actually update this information. So any Wikipedia can choose it as much as they like. So this is for this kind of data coming from Wikidata. The language links, as discussed earlier, are almost exclusively coming now from Wikidata for all of the Wikipedias. And then we have the authority control, often at the bottom of the page, where we say, well, this entity this page is talking about has this key in that other authority. The authority could be Music Brains, it could be the Library of Congress, it could be the European Statistical, they all have keys for those things. And what Wikidata does, it collects those keys and says, well, this entity is represented by this key in that data source. And in fact, it has more than 2,000 such external authorities to which Wikidata is linked now. This makes Wikidata, in some sense, Rosetta Stone of the web. You have a lot of different identifiers, and Wikidata tells you, well, those mean more or less the same in those different places. And more of the external authorities are actually going to Wikidata and actively maintaining the links to Wikidata. So we've seen this in particular with a lot of European central libraries. The National Library of Germany, of the UK, and others are now using Wikidata as an external authority file that they link to, and they keep the links up to date themselves. So we know that the quality of these are getting better and better. The Library of Congress is doing something similar. More and more museums are doing things like the Metropolitan in New York is doing such a thing, the British Museum in London, and so on. So we know that we are converging more and more on those items. Other places that are using Wikidata for linking is actually, I had this yesterday, I was presenting a similar talk to this, and had a person from Amazon coming to me, thanking me for Wikidata because they always had trouble that they didn't have budget data for movies. I was like, why don't you have the budget data for movies? You have IMDb. I mean, you should know that better than anyone else. And they were like, yeah, no, IMDb actually doesn't have budget data. They have a lot of other data, but budget data is kind of not usually publicly available. But Wikipedia collects this data and puts it into info boxes, and from the info boxes it gets to Wikidata. And his problem was actually now he has a movie, but he didn't know what's the Wikipedia article about the given movie. Like if you have Titanic, you don't want to get accidentally to the ship instead of the movie or something like this. So and thanks to Wikidata, we actually have the links to IMDb directly. So now he can just look up, okay, I have this IMDb link. What's the Wikipedia article, and then take the budget data from there. So this Rosetta Stone functionality of Wikidata is getting more and more used, and in order to help people to translate from one database to the other and connect data from all over the web. And in fact, this allows us to link out to many other places. Wikidata doesn't have to hold this data all by itself. It wouldn't make sense to put all of the census data into Wikidata. It's just too much of data. And this is also not data that you want to necessarily be editable. You want actually to say, well, the US Census, the US government has the official data. It's over there, and this is the identifier that we use for this town or county or whatever. And if you're interested in this data, look it up there. It's authoritative, and you know how to look it up thanks to Wikidata. And the same thing is happening with all of the web. We can point to a lot of different web pages and a lot of schema.org. Schema.org is also now using more and more Wikidata identifiers to represent the identity of the entities that are talking, that you are referring to. And schema.org is a pretty big success by itself. There are more than 12 million publishers out there on the web publishing structured data in schema.org markup. And this constitutes about 30% of the web. 30% of the web have now structured data in them that can be used, which is huge, which is just bigger than any knowledge graph out there. Data.commons.org is one of the projects that tries to actually collect those and package the data and give access to it. And there are other projects that you can use in order to get to this data. How is Wikidata doing? So I love this picture. So one of those is a photograph taken by NASA. And the other one is for every geocoordinate in Wikidata, just a little dot of color put on the black screen. Can you tell which one is the photograph? Who's for the upper one? Who thinks the lower one is the photograph? You win. The lower one is the actual photograph from NASA. The upper one is just generated from dots wherever geocoordinates are. But you can totally see.
The people that have edited Wikidata, where the geocoordinates are.
And so it's entities that have a geocoordinate, taking the geocoordinate and just put a dot there. So those are entities in Wikidata, basically, with geocoordinates. So people usually don't have a geocoordinate, so they wouldn't show up here. In fact, dead people, if you know where they insert, do get geocoordinates. That's an interesting ontological decision. But in general, it's more for like places and towns. But the similarity of those shows that you have a pretty good coverage of the United States. You don't get a similar picture for Africa or other places where the coverage of Wikidata is much worse. So there are more than 54 million items in Wikidata. This number has grown a lot in the last year because there has been a concentrated push to get scientific literature into Wikidata, and so that we can actually easier reference scientific literature in the Wikipedias and in Wikidata. So we want to get to a point where every single paper has actually an identifier in Wikidata, so that we have identifiers, so then we can easily access them and do bibliometric stuff on it. Currently, we are about 20 to 25% of that goal achieved, which is pretty amazing. There's a conference wiki site dedicated solely to this task. There are more than 650 million statements in Wikidata, and the number is growing very fast. What we can also see here is the different colors. So the yellow one is statements without a reference, and the red ones are statements with reference, so with one or more references. Also, the blue ones are statements with reference to Wikipedia, so this is kind of half-fishy. But you see that, that more and more data is actually coming in that has well-referenced sources outside, and the ratio of the reference sources to the unreferenced sources is growing very well. The other problem is for the unreferenced sources, people say, oh, this is terrible, Wikidata has so many unreferenced statements. But a lot of those statements are things like Barack Obama is a person. Where do you find a good reference for that? I mean, the New York Times didn't have an article actually telling us that he's a person. They have articles that are telling us where he was born, but not necessarily constituting the person. So it's kind of, what is a good resource for this kind of stuff? And do you really need references for all of this information? New York City is a city. Wikidata supports more than 400 different languages, and the number of languages is growing by like 1 or 2 per month, roughly. This doesn't mean that we have actually labels for all of the items, obviously. This is very, very unevenly distributed, unfortunately. This is the number I'm most proud of. There are more than 20,000 contributors to Wikidata each month. To put this number into perspective, this is the second largest wiki in the world. Only the English Wikipedia is actually larger. It's larger than the German Wikipedia, than any of the other Wikipedias, any of the dictionary projects, and it competes with the Wikimedia Commons for second place quite often. There have been more than 800 million edits to Wikidata since it launched in 2012, which makes this number already bigger than the English Wikipedia. And we estimate that around next year we'll probably get to 1 billion edits. And we'll probably have more edits than all of the other Wikipedias combined rather soon. My favorite edit in all of the time, by the way, is this little one. So my daughter loves the My Little Pony show. And there's a character called Spike, which is a little dragon. So this is the item about Spike. And Spike was changed from being a dragon to being a fictional dragon. It actually does make sense, and if you're interested, I can tell you later why, but it was just a funny thing when you see it the first time. So 860 million edits so far, and growing at the speed of about 500,000 to 1 million per day at the current rate. What's interesting is, and now this is the edit count over all Wikimedia projects, including Wikipedia and so on, since the founding of the English Wikipedia, which was the first one of those. So this was on January 2001. And what you can, so the green ones are bots, the yellow ones are humans. What you can see is 3 pretty distinct phases. The first phase, until about 2007, 2008, was the honeymoon phase. This is when Wikipedia started growing and started to get known, and everyone started to love it. And it looked like in about 2 or 3 years, every person on the world will be a Wikipedian, and everything will be described, and Wikipedia will have mission achieved in like half a decade or whatever. Then came 2007, and the curve flattened entirely. This was the so-called oh shit moment. And it was realized, oh, something's off. And for years, the foundation and researchers and others were trying to push this up somehow. All kind of ways were conceived that would changes to the UI, researching what happened here and so on. And no one, there are a few theories right now, but we don't exactly know what's going on. Maybe we just saturated the market of geeks. Maybe something else was going on. Maybe the communities are just not friendly enough, but what has changed in that? Yeah, so it's like, yeah, there are plenty of theories on that. And the number has been very stable over the next few years, over the next phase. And here, Wikidata launched. And what we can see here, the growth since then, is entirely attributed to Wikidata. So the Wikipedia is actually just go flat on. And everything on top here is Wikidata. And what we see is that basically half of all human edits to the Wikipedia projects are now currently going to Wikidata. And we expected actually that bot edits would constitute a much bigger portion in Wikidata than they do. We thought, well, 80 to 90% of edits will probably be bots and the rest will be humans. But in fact, the proportion is about 50-50. So on every bot edit, there's at least one human edit, which is quite surprising to us. We didn't expect humans to edit Wikidata in this rate, which were also why the UI is not particularly good, because we didn't expect people actually to do that.
So are bots edits basically when you're bringing data from other sources automatically, or what is the source of bot edit?
Yes, so bot edits can be various things. Everyone can just write a bot in Python, Java, or any other language. And they can, for example, just read external sources and upload the data. They can also look for inconsistency in the data and try to fix it automatically, or just mark it up as an error and similar things. So bots can do all kinds of things. But very often it's just uploading data from external sources. This is also a super surprising number for us. In the beginning, we didn't even put up a Sparkle endpoint because first we thought it wouldn't scale. And second, we thought no one knows Sparkle. We were wrong on both accounts. So together with the Blazecraft team, we put up a Sparkle endpoint. And first, it surprisingly scales. And the problem with the scaling isn't necessarily actually the size of the database alone, it's actually the edit rate. So we're having several edits per second, and the database is kept up to date on the fly. So we're usually just like 1 or 2 seconds behind with the Sparkle endpoint. So if you make a change to Wikidata and then make a query, basically you always get your change will always be reflected in the Sparkle query, which is really cool. And the other thing is that Wikidata has turned out to become the major learning vector for Sparkle. People start learning Sparkle because they want to be able to query Wikidata and get a query out of it. And there's a vivid community of people helping each other, teaching the intricacies of Sparkle and how to use it in Wikidata, and where they can ask questions. Like one of the favorite features is the ask for a query feature, where you like describe what you want to have, and then people come up and write the Sparkle query for you and teach you how to actually do it, which is pretty cool. The nice thing of the Sparkle interface that we're using is it's not only just giving you back an answer in tabular form. It has very rich visualization capabilities. You can annotate in the query itself that you want to have the queries be visualized, for example, as a photo gallery. And the Sparkle endpoint gives you this directly. And you can embed this in your website. You can just go to the Sparkle endpoint and see it. So you don't have to do any further programming. You just say, give me the pictures of Picasso and the pictures that we actually have in commons, and display them in the gallery. And you get this out of the box. Or here, these are space probe starts. Put them on an interactive timeline. So if this was now live, you could actually scroll left and right, zoom in, click on those things, and so on. And it's just a result of a Sparkle query. No further programming done at all. This is a bubble chart of the causes of death of persons in Wikidata in German. So you can just go and switch also the results, and so you have your heart attack, stroke, tuberculosis, cancer, and so on. What you see here is always like modeling questions. So you have here one box for cancer, but then here's several cancers like leukemia and others, stomach cancer and so on, and lower parts too. And so the question is, how do we actually model this, and how do we write queries that take this into account and so on? But it's still nice for visualization coming out of the box from a Sparkle endpoint. This is the population of Germany on a graph in other countries. And this is taking the geo coordinates and putting them on a map taken from OpenStreetMaps, just putting them on a map. And this is asking for the sister cities of Winterthur. And in fact, this was a query that Manuel Sachli at some point asked. He wanted to get a visualization of the sister cities of Winterthur. And he got his expected answers, the two cities in France, one in Pilsen in Czech Republic, the one in Austria. But then he also saw this dot over there. And he was like, that's weird. I don't know anything about it. The story is also even Manuel, so it has been about a decade now that Manuel has been working on the Winterthur article. And Manuel has in the meantime become actually a member of the City Council of Winterthur. And it helps editing the Wikipedia article. You probably just write yourself in as a City Council member. So he came to this query. He asked the Wikidata. He was discovering Wikidata, playing around with it, making visualizations like this one. I said, what's up with Ontario? So he's like, he looks it up. He looks into the English Wikipedia article and says, this has been there for a long time. Okay, let's see where this comes from. And he sees that it actually has a reference in the English Wikipedia. It points to the official Ontario government website, and they have a list of the sister cities, and Winterthur is among them. So he's like, okay, it's not a prank. His first thought was someone just added this, like, it's a prank, but actually it's on the website of Ontario. It has been there for quite a while. So he's asking as a city council member, he's like asking the archive an official question, like, do you know anything about this? And the archive is, nope, can't find anything. So he's asking the office of the mayor, do you know anything about this? And the mayor is like, no, never heard about that. We're also not doing anything with them. So no idea. So he sends an official letter to Ontario, California, and asks, probably more friendly than this, what's up? Why do you claim this? And they answer him. They sent him documents from 1982, nicely signed and filled out and everything. So with declarations of the mutual sister cityhood and everything. And the mayor who has signed those, the Winterthur mayor who has signed those, was still alive at that point. So he's not anymore, but he was still alive at that point. So Manuel went to him and asked him, do you know anything about this? And he's like, oh yeah, totally. I went there, had a great time, met the mayor, we hit it right off, and yeah, we made a declaration of sister cityness. And so he just forgot probably to tell it at home. With this information, Manuel again went to the archive. Now that he had the dates and everything, and actually now they could find the documents that they were filed, and they had this. So it's just they didn't find it in the first place, because again, it's hard to find stuff if it's not actually accessible to a machine. Because what do? You go through all the papers and try to read it. So thanks to Wikidata, Winterthur and local news media was reporting on this, found its long-lost fifth sister city. And since then, the relations between Winterthur and Ontario have been blooming since never since the 80s. So they found it, they revived it, and they find new friendship and discovery here. So with Wikidata, we're getting really a bit closer to this goal of letting everyone share in the sum of all knowledge. We're letting people now discover information better, visualize it in many different ways, share those visualizations, talk about it, make journeys through the data. What is missing? What don't we have yet? The most obvious question is, besides the fact that Wikidata is woefully incomplete, obviously, but besides that, is there more missing? And yeah, obviously, expressivity. Subject, predicate, object with qualifiers is not really sufficient to express the wealth of human knowledge. So let's take, for example, this sentence from the Ontario, California article. To impress visitors and potential settlers with the abundance of water in Ontario, a fountain was placed at the Southern Pacific Railway Station. How do I represent it in subject, predicate, object patterns that you can put into something like Wikidata? It's difficult. The next sentence will get even more difficult. The fountain was turned on when passenger trains were approaching and frugally turned off again after the departure. It's a great piece of Ontario's history. It's super hard to actually represent it in a knowledge graph and to make it accessible to answer questions. And this is a problem. Wikipedia today has more than 290 languages, and they have almost 50 million articles in those across those 290 languages. But as big as this number sounds, the languages are very differently represented. So English has more than 5 million articles. I mean, there's basically everything you can think of seems to have an English Wikipedia article. Every single Simpsons episode has a full Wikipedia article. And Cherokee has 942 articles. That's actually not even enough for the Simpsons episodes. Never mind for all the covers that are important in the world. 15 languages have more than 1 million articles, where you can say mission complete. We have covered everything important, but most of the languages, less than 10,000 articles. And it's not just the number of articles which are different. So this is the introduction, the header of the article about this German city of Frankfurt in the English Wikipedia. After the header, we get to the table of contents, which goes over 3 full pages. You have 21 chapters about the history, about transport in Frankfurt, the cityscape, and so on. The article is long. If you print it out, it's like a booklet. If you go to the Catalan Wikipedia, the article is slightly more terse. It basically tells you, well, it's a German city in the state of Hessen. It has a population of 732,000, which by now is outdated because they're not taking the data from Wikidata. It's like a 10-year-old number. And there's a link to the Frankfurt Football Club. That's it. That's all what they have there. And it's not always only that the English Wikipedia has a lot and the other languages are smaller. It really depends on the topic at hand. For example, if you take the port of Călărași in Romania, this is the English Wikipedia article. It tells you it's one of the largest Romanian river ports. It's located in the city of Călărași at the Danube River. And that's it. End of article. If you go to the Romanian version of the article, you get a lot of more information. Actually, you get a picture, you get a description, and all this kind of thing. So there's a lot of information that is locked away from you if you don't speak Romanian. And so just the size of the articles and the number of articles, also the coverage by topic. So English Wikipedia has 5.8 million articles. German Wikipedia has 2.2 million articles. What do you think is the number of topics that both of them cover? So what is the number of topics that has an article both in German and in English? Any guesses? Who's up for 1.8 million? Okay. 1.1 million, half. 600,000 or less. Okay, the middle was in this case the right way. 1.1 million topics are covered by the English and the German Wikipedia, which means the German Wikipedia has articles on over 1 million topics that don't even have an article in English Wikipedia. There's a whole lot of knowledge that we can't access if we don't speak German. And in fact, if you look at the top 10 Wikipedias, and each of them have more than 1 million articles, they have only 100,000 articles in common. Only 10% is the core of all those Wikipedias. The rest just goes anyway. If you look at the top 20 articles, you get down to 25,000 articles. There are 17.9 million distinct topics that have a Wikipedia article. And English only covers 30% of those. There are almost 70% of topics are not covered in English at all. There's not a single sentence about it. Other problem, community size. We have a total number of 69,000 active Wikipedians. Actually, it's a number, I think it's far too small, but the community, the foundation is always very proud of this. So 69,000 active Wikipedians. And English has 31,000 active Wikipedians. This is why English Wikipedia is so huge. A lot of people go to the English Wikipedia and edit there. As soon as you go to the German Wikipedia, which is the second largest, you get down to 5,500. The number drops off very quickly. And in fact, only 11 languages have more than 1,000 editors, which is a very healthy community, I would say, 1,000 people. And more than half of the languages have less than 10 editors. You have 10 people, less than 10 people, working in the free time on writing a full-fledged current encyclopedia. Not going to happen. Those projects are basically doomed. They can never achieve the goal of writing a full-fledged Wikipedia. There's just not enough people there. The root cause of this problem is that the cost of solving Wikipedia's mission is the number of topics that we want to cover times the number of languages that we want to cover. means in some unit, in unit of article cost. So this means we have 20 million topics, 300 languages, 6 billion cost. And one question is, could we turn this maybe into something where instead of multiplying those numbers, we can add them in a way? So instead, and reduce the cost totally, how would it even look like? So the suggestion here is, this is just a toy example. It really could be also something like AMR. So the suggestion here is we take some abstract representation of the content in some way, like, for example, well, this is ranking San Francisco as a city on number 4, etc., by the criteria and so on. And we then linearize, render this structured data into a sentence. Like, for example, San Francisco is the 4th largest city in California, after Los Angeles, San Diego, and San Jose. It doesn't really matter if it's this sentence or if it's a sentence like this, following Los Angeles, San Diego, and San Jose. San Francisco is the 4th most populous city in California. So we have some renderers of those structures into natural language, which is being called as soon as someone wants to read them. And then we can imagine those renders easily can work also in different languages, right? It could be, if we have those abstract representations, they could not only put it into English, they could also put it in German or something else. So we have those constructors, which obviously have to be community created, because we can't assume that any number of developers can come up with all constructors needed for Wikipedia. We know that so there are things like rankings that have these slots. Then we need to create the actual content, which is by far the largest part. So we still need 20 million topics about this. And we have to have people who actually can fill out those constructors. This is a major UX challenge to have those things flowing into each other. So we have the content, we have the constructors, and then we need renderers that turn this into this obviously completely pseudocode, which might even work in English, because English is such a nice isolated as synthetic language that it's actually easy to write this kind of patterns. So as you go to another language, it gets often much harder. But you can imagine this kind of renderers that turn the constructors into language. And that's it. Then we would have something like an abstract Wikipedia, a place where we write the content in an abstract way, which can access Wikidata, which has now also not only ontological knowledge, but also lexical knowledge. Wikidata has started last year a project where we're collecting lexicographical knowledge about words, keeping their forms and the information about it, like is it a female or a male noun in languages that make this distinction, or and how does the plural look like, and so on. So this kind of information can also come from Wikidata. To use this information in creating constructors, we have the contents per article, which means we basically write a series of those constructors one after the other, and hopefully can get in renderers that can turn it into readable articles. This sounds completely bonkers, and I'm sure that actually you understand the challenges in this very well. And the desiderata for the systems is that all of the pieces have to be editable by the community. And this is the big advantage over, for example, machine learning systems, because machine learning systems are not particularly editable for volunteers. But here, so we have to have the ability to easily edit the content. We have to be able to create new constructors, change constructors, to allow the renderers to be maintained by the community, because I don't expect that we have a team that actually can create renderers for 300 different languages. This is just too expensive. So we have to open this up to the communities to actually create those renders. Everything of these pieces has to be editable at any time, because this is how Wikimedia works. And we have to have something like graceful degradation. I mean, just because you're lacking the past tense of a certain verb shouldn't kill the whole article, but you should somehow fall back to a simpler version of the article or a smaller version of the article and still display something. So this whole sounds completely crazy, but there are also silver linings. First, we only have a single genre, encyclopedic text, which is extremely impoverished. We don't have to cover prose. We don't have to cover things like song texts, poems, or subjective descriptions. This is just encyclopedic text, and the exact wording often doesn't matter. So as long as you carry the content that far, it's kind of okay. Second big advantage is we don't actually need to understand and parse the language for this, which is often considered the hard part, right? I mean, generating language should be so much easier than actually parsing it, or never mind understanding. I don't even know how to understand language or what it even means, to be honest. We can also start super simple. The baseline is incredibly low. For most of those languages, there's no content at all for most of those topics. So the baseline is really low. And we can start very simple. We can see what works with those things, then build slowly to more and more complex things. We don't have to beat the article about the United States in the English Wikipedia, the first pass. I mean, this can stay for later. We can really start with those languages that don't even have an article about the United States and have only information like, well, the United States is a country, the capital is Washington. It was founded back in 1776, I don't know. So this kind of information, some simple stuff, and start from there, building more and more sentences, making it slowly more complex. The incentive infrastructure is extremely promising. And what I mean with this is maybe my strongest point. What I mean with this is today, if you have someone who's educated and speaks Georgian, what they often do is they don't go to the Georgian Wikipedia to add something, if they're interested in adding to Wikipedia at all. They'd rather go to the English Wikipedia because they know that their work there will have more impact. If they write about the history of their hometown in the English Wikipedia, they assume that more people will actually read it than if they write it in Georgian. They'll go to Russian, for example, because this is actually what everyone speaks in Georgia most of the time anyway, so why should they actually even bother with the Georgian Wikipedia? And they know that the Georgian Wikipedia, because it is only 7 active editors, they have no chance of achieving the goal of being an encyclopedia anyway, so what's the point of even trying? With this infrastructure, we actually tell them there is a point in trying. You can achieve a Georgian Wikipedia covering all those things. Maybe you shouldn't be writing on the content itself. Maybe your work is really necessary with the renderers or with the lexicographical knowledge and so on. And maybe we can have systems which can tell you which is most impactful for you to actually add the most bang for your contribution to this new abstract Wikipedia system. But we are creating a system where people's contribution can have much more value than they have today and reach more people and have more impact. And in the end, they would be all working on this attractive goal of achieving a world where everyone can share, which means to contribute to and access the sum of all knowledge. Thank you for your attention. We still have time, plenty of time for questions here.
So I'm curious about, this is Vrandečić talk, and I'm curious about the relationship now in terms of both Wikipedia and Wikipedia, right? Because you mentioned that some of the data comes from Wikipedia, some of the data in Wikipedia, popular data, and then there's the whole Wikipedia thing, which also comes from, I guess, a combination of.
Yes.
Yeah.
So I was always wishing that Wikipedia would set itself more up for pushing more of the data towards Wikidata and free their own resources for the more higher level stuff on top of the knowledge base. This unfortunately didn't happen as I hoped for. So what happened is that Wikipedia and Wikidata were for a long time just next to each other, and both had different strengths and weaknesses. And now it's getting more and more clear that Wikidata seems to be the resource which is more current, more actively maintained, and has more institutional support to remain as a resource for a long time. I really love a lot of the work that Wikipedia was doing. Wikipedia was one of the main reasons I could get people convinced to actually give me money for Wikidata, and just to show what could be done with this kind of thing. And Wikipedia is, from time to time, people from the Wikipedia project are tuning their tools so in a way that they can also be used inside of Wikidata. For example, to check the data against ontological constraints, to extract data from the Wikipedias and to load it actually into Wikidata and so on. And so the relationship between both projects is still developing and changing all the time. And I guess eventually it will be the situation that Wikidata is the knowledge base, and Wikipedia will offer numerous services on top of not only the Wikidata knowledge, but also other knowledge bases that they're trying to cover. So my understanding from the last chats that I had with the Wikipedia people is that they want to get away from being a Wikipedia only resource, but also to cover other knowledge bases and provide unified access to them and a merge of those. So, but both projects are developing and working their relationship out. As a researcher, I would today say, well, use Wikidata if you can. And if there's something missing in Wikidata that you would need for your work that Wikipedia has, let's port it over. Should be possible. Pedro?
Can you provide a bit more details on how you control or encourage the creation of a sensible ontology, on the properties and the classes?
Yeah.
That you think it's been successful, or what would you change?
I was intentionally removing myself from this process in order to allow the community to build it themselves. Also because I believe, and I still believe, that the community needs to have a sense of ownership of the ontology. And so I was telling myself, build them the infrastructure they need, that they can't build, but let them play around it themselves and figure it out. And I think the result is quite good. I wouldn't say surprisingly good. I expected it to be good. And it's quite good, and it has its flaws. Especially with species, for example, the ontology is often lacking connections and things. But they're building it out. They're working it. There are people who then devote in a burst work on the ontology and so on. The other part is that I'm actually not a huge fan of having strong ontologies in the first place. So Wikidata doesn't have a native idea of types, for example. Properties can connect any entity with any entity. And which helps a lot because it keeps the number of properties a little bit smaller because you can use them in several places. It makes also things harder because people have more of a white blanket paper problem. So they start to create an entity. It's like, so now what do I say about it? With a type, you can kind of more guide this kind of information. But we have found out is you can also guide it without having types because you can figure out, some things that have this kind of properties often also have this kind of properties. So we can actually suggest people what to add once they have created the first 2 or 3 statements. So there's no need for types in any of those places. And types are being used by the community in order to add quality checks on top of it. For example, you should only have a birth date if you're actually a living thing. But those are not strict rules. So because almost every rule has exceptions somewhere in the world. It's completely bananas how complicated the world is. And, saying something like, oh, this way you should only appear once, having this encoded hard into the software would have probably led to some place not being expressible enough. So what we rather do is let them say everything and then let other people take a look at it, clean it up, make queries which find weirdly looking things and let them then manually go over it and for it to clean up and so on. And so far, I would say the ontological work that the community has done has been very successful in the sense that it is a resource which is more and more widely used. So just from this pragmatic point of view, I would say it's successful. Is it a good ontology to actually describe the world? I don't know. It's a good ontology that helps the development of Wikidata right now. So this seems to be the case. If it's describing the world, I don't even know how to measure that. Yes.
I would like to know a little bit more about the conflicts because you were telling about different people having different truths. That's okay, but how do you distinguish different truths versus errors, right? Where sometimes in the data. So how do you address this kind of things?
So if the source data has actually errors in, we have the ability to enter it as a statement and at the same time mark the statement as deprecated. So famous cases of those is that the Brockhaus Encyclopedia, which is an important big German encyclopedia, has actually listed the length of the Rhine wrong. They switched two numbers, but it's a widely cited number. So yeah, we do say, okay, this is the number that according to this Brockhaus, but at the same time, we mark the statement as deprecated. It's like, please don't use it. We know that it's actually wrong. So for every statement, you can add this information. I skipped that in the data model, whether a statement is deprecated, normal, or preferred. The other one that's famous is the amount of iron in spinach, where I think the dot just moved one sign, which led to a lot of people feeding their children spinach because it's so full of iron and so healthy, and led to the development of Popeye as a marketing tool for spinach. But in the end, it was just an error in the data, but a widely cited and repeated one. We want to be able to actually express those, represent those, but also say, no, this is no good, this is an error. So we do keep them, but we have annotations on them dating their.
But I guess that involves a full manual process.
Yes, so, totally.
So I guess so my question was a little bit more about how do you conduct this process? Do you like flag them, or once you have some systems, you flag them and then you
right. So what users do is, for example, they create Sparkle queries, which are able to sniff out possible inconsistencies. And then they have a bot that takes the results of those Sparkle queries and marks the articles with some kind of marker. And then we have people, and those that are then collected on a wiki page. And then there are volunteers who go through those lists and actually say, yeah, this is fine, this is not, this is fine, and fix it manually. And sometimes people figure out ways to do it automatically, and then it speeds up the whole process and so on. But it's all a community process, and everyone contributes a little piece here. So I have someone writing the query, someone writing the bot, someone doing it all if the data set is small enough. We had those a number of times. For example, mapping the big catalogs between the national libraries, for example, there are tons of errors that the national libraries have, and they don't even necessarily know it. I mean, they know they have errors. I mean, everyone has errors in the data, and everyone is aware that they have. But it's hard for them to find it. And actually, they were really, really thankful for the Wikidata community going through this, cleaning it up, and giving it back to the national libraries. And they were super thankful in taking those and accepting those errors, or actually looking at them again and then accepting whether they are actually indeed errors. So there's this loop going on between professional organizations, the Wikidata communities, and cleaning up the data mutually and reaching together a higher quality level. But yes, this is all just processes that the community basically does on their time, their speed, and so on. We donated, for example, the Freebase data, a large set of the Freebase data to Wikidata. But we wouldn't just upload it to Wikidata because we thought this would be, back then Wikidata was so much smaller. So adding the Freebase data set would have created a sense of less ownership for the whole data sets for the community, because suddenly this big set of data is sitting there and who knows which errors are there. So what we instead did, we developed a whole tool around it, which allows people to actually see data from Freebase if they want to, in parallel to the Wikidata data, and then just make a few clicks and say, okay, yeah, load this into Wikidata, or not, or reject this actually and send this out. So this led to the fact that the transition took a much longer time, but at the same time, the sense of ownership seems to be there. So they still feel like it's their project, and what's there is what's there, or what they own. So it was, yeah, much more work, but I think it worked out in the end.
I think some
Actually, we have time for one more question.
And I'll let someone.
Is it possible for us to try and tinker with creating a constructor for your?
Yes, please. That would be awesome. Yes.
I'll ask. more about it
Yes.
afterwards.
I would love it because I have no idea how this will look like. I just threw up these things, but it's more strawman than anything. I don't think this actually can work. I don't know. And I would love something that actually does that. And it's not my realm of expertise, actually. I don't have a clue how to do these things. So yes, if someone, that's why I'm giving this talk. I want people to try it out. Yes, please, that would be awesome. I would be super excited about this. Because I think this might be the future of Wikipedia, but I have no idea how to get there. And that's why I need your help. And this room has a lot of smart people who could help with this. Okay.
Thank Denny for wonderful
Thank you.
talk.